Hello Gators, this is 6.6, Applying Properties of Definite Integrals. Let's take a look at these two integrals. We're going to start with 0, and the area under this first rectangle will be 2, and will be 2, and then 2 here, and then 1, -1, and then -2. So altogether, the area will be 2. This integral starts at 5, and starting at 5 we're going in this direction, which means our change in x will be equal to -1. Our height here will be -2, so the product will be a +2, a +1, a -1, a -2, and a -2, and this means that the answer will be -2. Notice that the answers are opposites of each other. Let's take a look at the properties of definite integrals. When you take the area from a to a, that means you have a 0 width, you are going to get no area. When you reverse the limits of integration from a to b of f of x dx, then you are going to change the sign of the answer. Let's take a look at multiplying by k means you're going to change the heights. Either they're going to grow or they get smaller. If you're multiplying by 2, then it'll get bigger. And this is the same as taking the constant out of the integrand and finding the area under the curve and then doubling it afterwards. This is the additivity for definite integrals, and it's when the upper limit and the lower limit here are the same. That means this boundary is the same. Then you can just pull the two integrands together as long as they're the same, f of x dx. Let's talk about when you have the integral of a sum. When you have an integral of a sum, the two y's are going to be added and there's going to be a higher y. And this answer will be the same as if you were to have separated it. And these are similar rules that we have with limits as well. And this will also work with subtraction. A to b of f of x dx minus, you can just separate it into two integrals. This one is talking about the area under the curve here, and this area under the curve is caught between two numbers. One, if you were to take the max value, which is this one right here, this is our max value, and then times it by the width, this is going to be the area of this large triangle, or large rectangle, and this large rectangle is bigger than the true area. Or if you were going to take the minimum value of f and then times it by the length of the interval, you will get a small rectangle, and the true area is caught between the two. The other is called domination. If you have a curve, f of x, that's y's are larger than the y's of g, then the area under f will be greater or equal to than the area under g. Let's go ahead and use these rules. Let's first notice that we've been given three integrals, and we're going to try to find these. Notice that I can rewrite this one. I can change the limits of integration from 1 to 5, but remember to put a negative outside. And I do know that 1 to 5 of f of x is -3, so I'm going to put a negative, and then I'm going to substitute here -3, and so the answer is 3. Over here, it looks like I can take these two integrals, the integral from -2 to 1 of f of x dx plus integral from 1 to 5 f of x dx, and that will be the same as this. This is one of our properties. So then I can just take 4 plus a -3, and the answer will be 1. On the next integral, I've done a little bit of work. I've separated the two. The integral of the sum is the sum of the integrals, and then I've taken the constant out. And once I've done that, I can go ahead and start substituting. I know this answer is 4 plus 2, and I know that this answer is right over here it's 8. And so this is going to be 4 plus 16, which is equal to 20. Let's take a look at this from 0 to 1. I'm trying to see if I can use these two, and I notice that I can add them together. I can't do any subtraction. This has to do with G, which you can't help with here. So for this problem, I just can't do it. Not enough information, so no answer. You just don't have enough information to figure it out. On this particular problem, I decided to take the 3 out, and I took the 3 out, and then I changed the limits of integration, and when I do that, I have to introduce the negative sign. And so now this will be -3, and I do know the answer from -2 to 1 of f of x, that is 4, so the answer is -12. Over here, this looks rather complicated, but what makes this easy is that the limits of integration are the same. And when they're the same, there's going to be a zero width on that interval. So the answer is 0. Let's take a look at piecewise functions and try to find the area from 1 to 5. And which means I'm going to find the area under the curve here, area under the curve here, here, and up to here. All right, and I can see these two areas are going to cancel each other out. So this will actually be 3 plus, and then this area right here is 1.5. And so the answer is 4.5. For this particular one, I graphed the absolute value of x minus 2, and I want to find the area from 0 to 5, which means finding the area under the curve. And these are two triangles. So that's going to be 1/2 base times height, and then the other one is 1/2 base, which is 1, 2, 3, and then the height is 3 as well. So this is going to be 2 plus, and then that's 4.5. So the answer is 6.5. Let's take a look at what the difference is between these two integrals. In this first one, all we have to do is find this answer, and after we find the answer, we just take the absolute value. So this is a negative area, and it looks like it's actually equal to this area right here. So these two areas, no matter they're semicircles, they're going to cancel each other out. So the answer inside the absolute value will just be this area right here, which is 1/2 base, which is 2, times height, which is 2. So this is the absolute value of 2, which is 2. Let's take a look at the next one. And in the next one, absolute value means that all our y's have to be positive. So this was underneath the x-axis. Now it has to be above the x-axis. Now this is, remember, a circle is pi r squared. And this is half of 1. So this is 1/2 pi, and then our radius is 1 squared. And this is going to be half of pi 1 squared. And again, this is 1.5. I'm sorry, this is 2. Area of 2 from here to here. So this answer is going to be pi plus 2. And I was supposed to go up to 4. Yes. All right, now let's take a look at how a calculator can do this. So I'd like to take a look at the calculator. And what I'm going to do is I'm going to put the integrand root x minus 1 in there. And then I'm going to I want to do graph. Let's have a graph here. And then I'm going to do second calc. And I'm going to ask for the integral, which is 7. And I want the lower limit to be the number 2, enter. And then I want it to be 3, enter. And then it'll figure out the area. And for AP purposes, you need to round to 3 decimal places. So this would be 1.219. So this would be approximately 1.219. 1.219. All right, let's go ahead and figure out the second one. And on the second one, I am going to go to y equals, and I already have, I'm going to turn this one off. And then turn this one on. And I'm going to have a graph. And I want to find the area between -2 and 4. So I'm going to do the same thing. Second, calc, I'm going to go 7. And then my lower limit is -2, enter. And then my upper limit is 4, enter. And there's my area. My area is -4. I really didn't need a calculator for this because this could have just been done with triangles. So the answer is equal to 4. And this is the end of the screencast.